Hi, and welcome to another question on geometry from the Best of XAT series. What I would suggest is you look at this question, try it out on your own, and then have a look at the solution that will follow. If you are going to take the XAT and are wondering what exactly to do over the next few days, we have a very special video for you in which we have discussed the pattern of the test, the sectional cutoffs, the preparation strategy, and the attempt strategy. You can visit the video by clicking on the I button above or from the link in the description box below. Happy learning. Now this is a rather interesting question because you have two right angled triangles. You may or may not be able to figure out that PO is perpendicular to AO, and there are a couple of options which talk about tan inverse 2 by 3 and tan inverse 3 by 2. Now these are all cues that will throw you off and you will probably not want to attempt this question because there seems to be a bit of trigonometry involved. But as we have seen in one of the previous questions as well, whenever it comes to trigonometry, you can't really make a call without understanding what the question is trying to ask you. So in this case, what we can do is we can simply play along. Let's complete the diagram, read the information, and then let's see what exactly it is that we need to apply. So in this case, we have two right angled triangles OAB and OQP, which is obvious. Right angled at A and P, again you can see that. Having common vertex O, again this is fine. There is one small thing that we have been given here which we need to understand so as to solve this question, which is AB and OP are parallel to each other. So AB and OP are parallel to each other. That tells us that if AB and OP are parallel to each other and if AB is perpendicular to OA, then PO should also be perpendicular to OA. Once you figure this out, the next logical step will be to construct this entire figure that we have here. So if you observe carefully, we have to find out the value of angle QOB. So if you look at it, we have three right angle triangles, or we have three right angles here that you can see. How can we find the fourth right angle? By simply constructing this rectangle. So if you expand this thing, let's say we are looking at some point S here, and we say that PS is perpendicular to AS, then I have a nice rectangle here PSAO. Now once I have got this rectangle, I have to understand what is the value of angle QOB. So let's try to fill in the values and complete this rectangle. So if you look at this, you have OA equals 3. In a rectangle, the opposite sides will be equal in terms of length. If PQ is 1, QS becomes 2. Similarly, if AB is 1, then BS becomes 1 because PO will be equal to AS will be equal to 2 units. Now we have figured this part out. Similarly, if you look at the length of side OQ, it's very obvious. 2 is one side, 1 is one side. The hypotenuse has to be root of 2 square plus 1 square, root of 4 plus 1 or root 5. Similarly, in this case, the hypotenuse has to be equal to 3 square, 9 plus 1, 10, root of that. So root 10 will be the value of OB. What we have to find out is value of QOB, the angle. Now there is one very interesting thing that you can observe. You had a triangle here wherein 2 and 1 were two sides that made the right angle, and so we could figure out that root 5 would have been the hypotenuse. Can you spot any other triangle that gives us the same insight? Of course there is. You can see this triangle QSB that we have here. Now if you look at this triangle QSB and you join QB, let's say for example, if one side that makes the right angle is 2, another side that makes the right angle is 1, then the hypotenuse has to be equal to root 5. Now you can see a beautiful triangle here OQB wherein two sides are root 5 and the third side is root 10. In any triangle wherein the sides are in the ratio of 1 is to root 2, we can say that that triangle is going to be a right angled isosceles triangle, or in other words, it is going to be a 45, 45, 90 triangle. So we can obviously say that measure angle QOB in this context is going to be 45 degrees. And so our answer here is going to be option 2, that is 45 degrees. Not at all a difficult question, no application of trigonometry whatsoever. Although you could have made things a bit difficult for yourself by getting into sine rules, cosine rules, getting into tan inverse of angles, tan inverse A plus tan inverse of B, all these things you could have done in this question. Still you would have been able to get the answer. But just because one of the options or a couple of options say tan inverse, it does not mean that you have to apply trigonometry in this particular context. So again, when it comes to these kind of questions, don't worry about trigonometry. Give it a shot once, Stay on that question for 30 seconds, a minute, draw the diagram and then decide whether you want to go ahead with the question or not. So I hope you have understood the concept and you will be able to attempt these kind of questions if they appear at the XAT. If you have any queries or any doubts in terms of this question, please feel free to comment in the section below and we will get back to you on this. Happy learning.